Hi everyone, so it's Coach Fred, and today's SAT video we're going to be talking about systems of linear inequalities. And a system of inequalities, or system of linear inequalities, is basically two inequalities of the same variables that have a common solution. And so from Algebra 1 or Algebra 2, you might remember that a system of linear inequalities would involve when you had to shade with your graphs. So let me review. So here I have two linear equations. I see that they're linear because the highest exponent of x is 1 and y is 1. And they seem to be in y equals mx plus b, so slope-intercept form. So a couple things to know about systems of linear inequalities. If I use less than or equal to or greater than or equal to, I'm going to use a solid line. So it'd be solid. And if I just use less than or greater than, it's going to be a dotted line. And then we shade based on that. All right, so I'm going to look at the first one. I'm going to call this line 1. I'm going to do it in blue, and I'm going to call this line 2. And I'm going to graph them. So remember, I can graph the y-intercept. The y-intercept is the point 0, 2. So I'm going to go up the y-axis to the point 0, 2. And then my slope is 1/2. So I can rise 1. And to the right 2, so up 1, right 2, or I can go down 1 and to the left 2. And so I have 3 points, and it is less than or equal to, so I'm going to graph. Take my line, it's a solid line. I'm going to put it through my points, make that a little bit nicer. So maybe something like that. Okay, and then I shade it. Okay, so I'm going to shade this one in blue, because this is line 1, okay? Now, it says y is less than. So I look at my graph, and I go to the y-axis. Y's that are less than will be below the line. So I would shade below the line. So that's one way of considering it. Another way is to use a test point. A test point would be to pick a point such as 0, 0, plug it in and see if it makes the equation true. If it makes the equation true, then it is in the shaded region. So if I put in 0 for x and y, I get 0 is less than or equal to 0 plus 2. So 0 is less than or equal to 2. It's a true statement, so the point 0, 0 is in the shaded region, so I would be shading below. All right, now I'm going to go to the other line, to line 2. I'm going to go down to that y-intercept of 0, -3. So 1, 2, 3. And in this case, I have a negative slope. So I'm going to go, if I go up 2, I have to go to the left 1. And I could do that again, up 2 and to the left 1. And then I'm going to take my line, and I'm going to draw a line through that, like that. And then I have to shade. Okay, so it says y's less than, in this case as well. So that's going to be below the line. So everything below the line. So I'm going to shade like that. And we can see that the overlapping region is right here. Okay, actually, let me use a highlighter because I think that might be better. So my overlapping region is right in between these corners. And any point in that shaded region is a solution to this system of inequalities. All right. Now, how are you going to see it on the SAT? Okay. The SAT is going to see, they could have you graph and say which one of these is the shaded region. They could ask you all different types of questions, but I saw one recently I really liked. So we're going to look at it. This was the inequality. Y is less than or equal to -15x plus 300, and y is less than 5x. It says in the xy plane, if a point with coordinates a, b lies in the solution set of the system of inequalities, what's the maximum possible value of b? So, okay, I like they do this, but what they're trying to trick you. They're saying, okay, this is just xy. But instead of calling it xy, we're going to call it ab. So that way, it's a little bit different than the xy used in your equation. All right, but if I'm looking at a linear system and I want the maximum y would be the point where the two lines intersect. It would be the y coordinate. Now, you could take the time if you wanted to kind of draw a quick sketch of this. So I'm going to quickly do that so you can get an idea of what I mean. So I've got this line, y is less than 5x. I'm going to call this line 1 and this line 2. and y equals 5x is just a line going through the origin, has a slope of 5. So maybe something like that, okay? And then y is less than or equal to negative 15x plus 3,000. And actually, we'd be shading below, so let me just do that. And then, so I've got this 3,000 way up here, going down 15 over 1. So I have a line, and I don't have to be exact here, looking something like that, okay? And I want y is less than. So that would be shading here. So I'm actually looking for the point of intersection, and I'm looking for the y coordinate of that point of intersection. So I'm actually going to treat this like a system of equations. I'm going to make this y equals negative 15x plus 3,000. And this one y equals 5x. And I'm going to actually use substitution. So I'm going to plug 5x in for y. There, I've got it. And then I'm going to add 15x to both sides. So I get 20x equals 3,000. All right, so now I'm going to divide 3,000 by 20. And I get 150. So x is 150, but I need the y coordinate because that's what it's asking for. So I know I have an x of 150. And so I'm going to take 150, I'm going to multiply it by 5, which is 750. So what is the maximum possible value of b? Well, then it would be 750. Now, if these lines were dotted, though, and they're not, they're solid, but if they were dotted, we'd have to be careful because it couldn't actually be that value. It'd have to be a little bit less than that value. So I just want you to think about that as an idea. Why I did that, why I was looking for a maximum possible value, why it was that corner point, because the overlapping region was right here. That was where I was trying to get a solution to it. But I thought this was a really great question, a really great use of systems of linear inequalities. All right, hopefully that was a helpful video. Have a great day.